Hello and welcome back for another VMK in the game development series. In this VMK we're going to use the GUISlider class that we created in the previous VMK, and we're going to implement it into our game engine so that we can see how the slider works inside of our code. To begin, let's go into Paint Shop Pro and take a look at how I modified the GUI.tga file. I added this one slider here, which I just rendered some little notches onto it because I want to demonstrate both a continuous sliding slider and one that has discrete step sizes. So this one here I'm going to use for discrete step sizes, and you'll see that we're going to be using this guy a little bit later whenever we want to specify the quality factor for images that we load into our game engine. And with the quality factor, we know we're going to have 4 different levels: quality 1, 2, 3, and 4. So what I've done is I've spaced all of these out equally, and this is going to be quality factor 1, quality 2, quality 3, and quality 4. This bottom slider doesn't have these little notch marks, so when we use this image for our slider, we can slide all the way across, and we won't be sort of stepping from one spot to another. These are the actual slider controls that the user will be able to grab and manipulate. So these will be rendered over top of our slider bar. And the way that I generated I did the same thing as with all the other buttons, where I created an image. Actually, let me turn the alpha here off. I created an image here, and I moved it over a certain number of pixels, just changed the color so that when we're not over top of it, we'll have this blue arrow that we can manipulate. However, when the cursor goes over top of this arrow, then it's going to turn red, and that's this guy here that's going to get rendered. I also added an alpha channel right underneath here so that we won't be rendering the white space all the way around this arrow. So as we're rendering it over top of this bar, you'll just see the arrow. You won't see this big rectangular block, because when we render this part here inside OpenGL, we are going to be using quads. Okay, so that's the geometry or the image that we're going to be using for the TGA file. Now let's go into our code and make some modifications so we can render this slider onto the screen. We need to go under Scene Initialize. This is where we're initializing all of our GUI controls. And let's see here. We're loading in the texture that is going to contain all the images. And here we have our GUI button, GUI radio. So now we're going to add our GUI slider. And when we do that, we also need to go into here and add our new header file. Like so. And now we can go back into here. We can leave this variable as it is. And what I'm going to do is I'm going to get rid of the radio buttons just so that I'll be demonstrating the slider by itself. Okay. Okay, so here's the code on how to implement our slider inside of our game engine. We're going to call new on the GUISlider constructor, and the parameters we're passing in here are the ID number, so I'm just using some value that we have access to here. Doesn't matter what we have here right now because we're going to be changing this a little bit later. The second parameter is the size of it, so it's it's the position where we want to render this object on the screen. So I just picked some coordinates here, 405, 412. Then we have our size, so this is the overall size of the bar that the slider is going to be sliding on. Then we have our offset, and this offset tells us how far are we going to be rendering that little arrow with respect to the current position of this slider bar. So we want to offset it horizontally by 15 and downward by 8. So what this is going to do is it's going to actually center the arrow in the middle of our bar rather than just having it lined up flush with the bottom. I'll show you this in a second once we get this code running. The next parameter is whether this slider is horizontal or vertical. Well, we've seen that inside of the TGA file, our slider bar is horizontal, so we specify true here. And then the last 3 parameters are the value, the minimum, and the maximum. So the value is where the arrow is going to be pointing initially on the slider bar. And because I've chosen the minimum and maximum to be 100 and 200, and the value is 150, the arrow should be located right in the center of our slider bar. And then as we're sliding, we can move it down to a value of 100 or up to a value of 200, and you won't be able to go beyond these two values. If everything initializes okay, then what we do is we assign our texture to our slider, and our texture, we only need to make one call, unlike the GUI button class where we had to make one call per texture image. Here everything's wrapped up into this one assign texture function call. So we're passing in the texture ID as the first parameter, then we have the bar's bottom left hand corner and the bar's top right hand corner. So these two coordinates here define the overall size of the texture image that's going to be representing the bar. The next value here is the slider's bottom left-hand corner and the slider's top right-hand corner. So these two coordinates represent the values for the location of that arrow, and that's basically going to be one of these. It's probably this one here and this one here. Then the next parameter we have is the offset. And the offset says that the next parameter is going to be -43 and the x and 0. So sorry, going back here, the first coordinates were for this location and this location, and then the second value, which is the highlighted one, we say is going to be -43 pixels to the left and no changes in vertically. So what we're going to do is take the coordinates here and just shift them 43 pixels to the left, and that'll give us these coordinates here and here. So rather than having to pass these sets of coordinates 3 times in by calling assign texture, we just wrapped everything up into this one assign texture call for the slider, for the GUI slider. And the last parameter is the maximum size of our texture image that we're using. And again, we need to know this so that we can scale all these coordinates here from pixel values to texture coordinates. After we do all that, we need to push our slider control onto our container, which is going to be containing all of the GUIs for a specific menu. So we see that here. We just take the GUI control member variable, and we're specifying this control is going to go under the menu, and we're just going to push it back. So let's go and save this. Let's try to compile this. And there's some warning messages. Oh, right. I'm not using the P button or P radio anymore because I deleted them, so that's okay. Okay, let's build our project and give it a run. Alright, so here's our slider. You can see as I move my cursor over top of the bar, the actual arrow here is highlighting. So the way that the functionality for the slider works is you don't necessarily have to be over top of just the arrow part for the highlight to occur. You can be anywhere inside of the region that's defined by the bar. Oh, and here's the, as I was saying before, back here when we specified the -8 here, that -8 was so that this arrow here is offset downward by 8 pixels. If we didn't do that, then the bottom point here of the arrow would be flush with the bottom of our bar here, and that's not really what I wanted. So I moved it all down slightly so that it sort of overlaps a little bit, like so. Okay, so as I was saying, if you move your cursor anywhere over top of the bar, you see that the arrow part here highlights. And then when I click and hold the button, then I can drag this arrow part left and right anywhere I like. Now, the way that the functionality is programmed right now is that I can press the button and I activate the control. And then as I'm moving left and right, the slider is actually moving with me. If I move my cursor up here, I'm still locked onto my slider, so it just continues moving. It won't stop moving until I press the button again. And I can only do that if I'm highlighted over top of the slider, like so. So if you're pressing and holding the button, it's going to work fine. And as soon as you let go, you have to go in and press it again. So if that's not the sort of functionality you desire, we can go in and change that as well. But that's the way it's currently programmed in to work. If you go and highlight somewhere not where the arrow is and you press the button, you'll notice that the arrow automatically jumps to where your cursor was located. So if I'm over here and I press the button, notice it jumps right to it. What else? Oh yeah, if I press the button and I activate the control and then I move beyond the minimum value here, notice that it sticks and it doesn't go beyond its minimum value. Same thing with the maximum. If I try to go beyond the maximum value over here, it just stops moving and it actually will not let you go any further. Same thing if I go up or down, it just slides horizontally, it doesn't move up or down at all. So that's a continuous sliding slider. Let's go back into our code. Now you saw the functionality of the slider where when we pressed on top of the control we would activate it, but then it would stay activated until we press on it again. That's not a real sort of normal functionality for a slider. So what we're going to do is modify our code slightly so that it behaves more like the Windows ones, where you can click on the slider and as you're clicked and holding it, you can move it around. But as soon as you let go of the button, it doesn't continue moving with you. And that change is relatively easy because we've already incorporated the code that does all the work for us. We just need to implement it inside of our game OpenGL class here to use the code that we've implemented. So to do that, we can go into here under message handler. And what we want to do is handle the case of when we release the mouse button. And that happens here under L button up. And currently what we're doing is we're saying that the left mouse button is released and we're taking the user settings and setting the mouse's left mouse button to be false. And this basically sets the value inside of the PUser settings to let us know that we're no longer holding the mouse button down. But we also need to do one other thing here. If our scene graph is already initialized, we want to call this function here GUI check release mouse. And we're going to be implementing this function in this video, which will be calling all the release mouse button calls for all the GUIs that we have. So let's go and save this and then go into our scene.h and implement this new function. So let's scroll down into our scene class, and underneath GUI check hotspots, we're going to add GUI check release mouse. And let's go into our CPP. We'll take a look under, let's see here, scene GUI check hotspots. We'll just write this code right here underneath. This guy's responsibility is to check all the GUI controls for deactivations. And the way we do that is we have our list of all our controls that are currently being used for this specific game state. So we can get the game state from the PUser settings and dereference our container that has all the GUI controls. And then we're going to find out exactly how many controls do we have. For every single control, we're then going to go in and call stop pressing. And you'll remember, for every single GUI that we created, we ended up creating this stop pressing function. And the reason why we did this is because certain controls, maybe we want to have some sort of functionality when we release the mouse button. So you'll see here under the GUI button, we have stop pressing, and that's set pressed. Stop pressing is right here. It doesn't do anything because we didn't want any functionality here. If we do want some functionality, we just put it into here. But the one we're interested in is the GUISlider. And we'll go into here now, and you'll see that whenever we go in and clean up the section where the mouse has stopped being pressed, what we're going to do is set the m_b pressed value to be false. What this is going to do is then detach our mouse from our actual control inside of the slider, allowing us to no longer control it. So let's save this now and compile it, make sure everything's okay, and build it. Okay, so once again, I'm moving my mouse cursor up and around my bar here. If I press on the arrow, I move it, but I'm no longer stuck to it. So you notice if I click over here and I press, it moves, but notice it's no longer activated. If I press and hold, I can continue moving, but as soon as I let go of the mouse button, it stops moving. So that's more in line with how a Windows slider works. And the other thing is when I press and hold the mouse button, if I move away from the region, I can still continue moving it, but I still have to maintain that mouse button pressed. As soon as I let it go, you notice that I let go of the slider and it stops moving as well. So now we have a more realistic control for a slider inside of our game engine. The only other thing I wanted to show you in this VMK was how to add in the notches into the sliders. Again, this is pretty easy to do because we already have all of our code written to handle this. Okay, let's go into our scene under initialize again, and this time we're going to create a second slider, and this slider will be notched because we're going to give it a step size. So right underneath the first slider, we're specifying the following. We have GUI slide quality, and we have some coordinates for where we want to locate everything. And then notice here we have the value, the minimum, the maximum, and then the last parameter is 1. Before we didn't have a fourth parameter here which specifies the notch. Instead, we just use the default, and the default is set up to use a continuous slider. If we do set up a value in here, then what we're doing is we're specifying that we do want to have a notch slider which will only notch for whatever value is specified here. So that's the only real change I've made, and let's just scroll in here. Yeah, at the bottom here we just have texture coordinates, and then we're pushing our new control into that same menu. So let's build this now and give this a run. So here we go, we have our two sliders. We have our continuous one, which slides normally, and then we have our notched one. And notice that the notched one only goes from the designated values here. So this is 1, this is 2, 3, and 4. We cannot slide anywhere in between. And also, the functionality is built in such a way that if I press and hold the mouse button and I move to the left, it won't jump over to the next section till I've moved halfway between this one and this one. So that's why I have to move a certain region before it jumps over. And same thing going back the other way. I have to go halfway between these before it jumps over to the next section. So there we go. That's pretty much it with the sliders. They're all relatively simple to use with the GUI interface. You don't really need to worry about the back end if you are comfortable working with everything up front. Oh, there's one other thing I wanted to show you, which I think is relatively obvious, and that is whatever value you specify here is the value that the slider is going to initialize to. So we've seen here that between 100 and 200, I've set up to be 150 here, that arrow is located right in the middle. If I specify this to be like 110, it's going to be located close to the left side, almost right at the minimum. But notice what happens here if I set this guy up to be 2.5. Because he is set up to be notched between 1 and 4 with step size of 1, 2.5 is not really a valid number. So let's see what happens. The slider itself isn't located at 2.5, which would have been right here in the middle. Instead, it has been rounded down to be a valid value, which happens to be 2. This guy here, which is at right now at 110, is perfectly okay because there is no restrictions on where he can slide. So just something to be aware of. If you are using notched values for your slider, make sure you're specifying valid values, or else you'll notice that the slider is being rounded to a nearest section that is valid. So the code is implemented to fix itself, so you don't have to worry about it too much. But if you are, programming something and thinking, oh, this slider should be here, but it's not, it's most likely because you're giving the slider a value which is not allowed. Okay, that's it for this VMK, but I did notice one bug, or not really a bug, or an annoyance that is present in our code here. Let me demonstrate what I mean. If I go and close this application using the X, you notice that we return, and the return code here is 0. Anytime your program exits with a 0, that means that everything destructed correctly and everything is fine. However, if you do see a return code here, most of the time this means that there's an error. However, in our case, that's not true, because what we can do is press a tab, and for instance, we've pre-programmed that if I press the Q key here and press enter, our application will close. But notice down here, it returns with an error code of 13. When I first saw this problem, I was scratching my head trying to figure out what's going on here. What does error code 13 mean? And I was going through some documentation online with MSDN. Finally, I realized, wait a minute, 13 is the ASCII code for the enter key, which is the very last thing that I pressed. And if you take a look at the way that our code is written, inside of game OpenGL, well actually, let me show you where this return code is coming from. If you go into the main, and right at the very end here, our program exits by returning a return code. And the return code comes from start message loop. Because what we do is we create our window, which is where we're rendering everything, and then we call start message loop. And this guy is going to be running our program until we quit. Once we quit, it's going to return a value, and then we exit. If there's something wrong here, we're going to show an error message, set up our return code to be -1, and then we exit again. So this guy here is returning 13 to us. So let's take a look at what he is actually returning. You notice inside of here, we're doing this loop here that is looping until we quit. However, after we quit, we clean up, and then we take the last message, wparam, and return it. Well, the last message that we get whenever we press enter on the keyboard happens to be the enter key. So the value here, wparam, is going to be the ASCII code for the enter key. And well, we could also get other different kinds of error codes here that are not really errors, but rather normal processing inside of Windows. So just to not get confused with what's going on with these error codes, what I recommend to do is just take this and replace it with a 0. So we know that anytime we exit out of this while loop, we're going to be returning 0, and that means that there was no error message. The only time that we have errors generated from our program is if we cannot create our window, and then we go through here to show the error message, and then we return -1. So now if I go in here, compile the code, and give it a run, and again, press the tab, press Q, and press enter, now we return with an error code of 0. Okay. So that's it for this VMK. Come back for the next one, where I believe we're going to be adding another GUI element, and this guy is going to be handling all of our text inside of our GUI.